Very good morning to all of you. Can you hear me? Nutan, very good morning. Can you hear me? Please tell me. Am I audible to you or not? Okay, Omkar is saying yes, sir. Sandesh is also saying no. Very good morning to all of you and welcome back to the chemistry lecture. Okay, so what we were talking about? Nutan Sabha is saying yes, sir. Okay, चलो मेरी आवाज आ रही तो we will start our lecture. What we were talking about? We were talking about the chemical kinetics, and in that chemical kinetics we have seen different types of orders: first order, zero order, second order. Okay, and in the last lecture we were talking about the activation energy, and we have derived the Arrhenius equation. We have derived the Arrhenius equation of activation energy. Now there are two ways by which we can derive energy of activation or Arrhenius equation. First way is Van 't Hoff isochore, and from the Van 't Hoff isochore we will get the energy of that equation in differential form. From the Van 't Hoff isochore we will get equation in differential form, and another way is Maxwell-Boltzmann distribution law, and from this Maxwell-Boltzmann distribution law we will get Arrhenius equation in the exponential form. And today we will derive or we will see how to determine the energy of activation, how to calculate the exact value of energy of activation for any reactions. For example, saponification reaction is there, esterification reaction is there, and we were doing kinetics for that reaction. Kinetics means we were monitoring that reactions with respect to time, that is called as a kinetics. Monitoring or we will calculating the speed of that reaction. Okay, and from this data if you want to find out the value of energy of activation, so how will you find out? So two equations are there, two methods are there. One method is graphical method and another method is analytical method, and by using these two equations we will find out the exact value of energy of activation for that particular type of reactions. And these two equations are there. First is graphical method and second one is analytical method. Okay, and after deriving this equation we will solve problems based on energy of activation. Okay, so before going to the actual lecture I want to tell you that please take pen and notebook, because uh, yes, please take pen and notebook, because in this today's problem we are going to solve some numericals based on energy of activation. Okay, so shall I start the lecture? Hmm? Shall I start the lecture? Yes or no? If you can hear me, reply me in chat box so that we will start the lecture. Yes, Pramodini and Rupesh Kumar is saying yes, sir. So, okay, we will start the lecture. Okay, Rameshwar, Vaibhav, Abhishek, they are saying yes, sir. Okay. So, we'll start the lecture. Alan is also saying yes, sir. Okay. So, this is your lecture number 6 of chemical kinetics. ये आप लोगों का कौन सा लेक्चर है? लेक्चर नंबर 6 है केमिकल काइनेटिक्स, एंड टुडे वी विल डिस्कस the determination of activation energy. So this point we will discuss, which is very important. There are in your exam there are some problem based on this determination of energy of activation. इसके ऊपर एग्जाम में हमेशा प्रॉब्लम रहती है to find out the activation energy or to calculate the activation energy in different units. So there are two methods. First method is graphical method. So by using that equation we will derive that equation, and which is y is equal to mx plus c form, and by using this equation you can plot a graph, and from a slope you can find out the energy of activation. Okay, and another method is analytical method. So two methods are there, so we will see one by one. Let us start with the method number 1, that is graphical method. So we have this equation, you know that we have derived this equation dlnk. This is Arrhenius equation in differential form. We have derived in the last lecture. Okay, dlnk by dt is equal to Ea by RT square. This is a Arrhenius equation in differential form. That means we have derived this equation by using one top isoquant. Okay, so we have this, we know this equation, that is dlnk by dt is equal to Ea by RT square, and we will rearrange this equation. We will rearrange this equation, and after rearranging, what we will do? We will transfer this dt, which is in denominator side. We will transfer this dt into the right hand side. हम लोग क्या करेंगे, ये यहाँ पे क्या था, डिवाइड था, इधर जाके क्या हो जाएगा, ये मल्टीप्लाई हो जाएगा. ठीक है. सो आफ्टर रीअरेंजिंग दिस इक्वेशन वी विल गेट dlnk which is equal to Ea into dt divided by RT square. This is your equation number 1. So we have this equation after rearranging your Arrhenius equation. ठीक है. Okay. Then now we'll integrate this equation. Now we'll integrate the equation number 1. Okay, and after integrating we will get dlnk integration of dlnk is equal to integration Ea into dt divided by RT square. Okay, now here we will assume this Ea is independent of temperature. Ea does not depends on temperature. We will assume this, and this R is gas constant, you know that. So we will put these two terms outside the integration. Ea and R we will put the outside the integration. Okay, what we will do? We will assume Ea is independent of the temperature. Ea is independent of the temperature, and this R is a gas constant, so it is a constant. We will put this Ea by R outside the integration part, and after putting this we will get this equation. The integration of dlnk equals to, we will put this term outside the integration, Ea by R integration dt by t square. Okay, after integrating we will get this. Now we will solve this. So we will get lnk is equal to Ea by RT into minus 1 by t plus ln A. We will get this, and this is our equation number 2. Okay, this is our equation number 2, and this ln A is integration constant. ln A is called as a integration constant. Okay, in the equation 2 new term is there, that is ln A, and this ln A is called as a constant of integration or integration constant. Okay, then this equation 2 can be written as, so we will rearrange this equation. What we will do, we will transfer this ln A into this left hand side. So lnk minus ln A, which is equal to minus Ea by RT. So after rearranging we will get this equation. In the first steps we have transferred this ln A to this left hand side, and we have multiplied these two terms, Ea by R into minus 1 by 2. So we will get lnk minus ln A is equal to minus Ea by RT square. Okay, now we will solve this. lnk minus ln A, we will write this ln k divided by A. We will write this, which is equal to minus Ea by RT, which is equal to minus Ea by RT, and it is nothing but the exponential form of the Arrhenius equation. K is equal to, this is nothing but the exponential form. K is equal to A exponential minus Ea by RT, and from equation 2, here equation 2 is there, here equation 2 is there. So from equation 2 and this part we will write ln k is equal to ln k is equal to ln A minus Ea by RT. By changing the base 10, now here ln tha, so we will change it to the base 10. We will get ln, so we will get 2.303 log k, 2.303. We will change ln to log, so 2.303 log k equals to 2.303 log A minus Ea by RT. This we will get, and after rearranging this, we will transfer this log 2.303 to this side. We will get log k is equal to log A plus minus Ea by 2.303 R 1 by t. So this we will get this equation number 3. We will get this equation number 3, and if you look at this equation, it is nothing but the y is equal to mx plus c. This equation is nothing but in the form of y is equal to mx plus c. So this is C term, this is Y term, this M is square bracket term, and X is this term. So if you plot the graph, Y axis we will take log K, and X axis we will take 1 by T, and after getting this M is nothing but the slope, M is nothing but the slope here, and which is equal to minus EA by 2.303 R. This is your slope. So slope is negative, that means the nature of the line is negative, and we have intercept on y axis, that is equals to log A. So that is equals to log A. Now if you plot this graph, the nature of graph will be like this. The graph will be straight line. Okay, graph will be straight line. So we will plot a graph. On y axis we will take log K. On y axis we will take log K, and on x axis we will take 1 by T, temperature, and here we will take log K. Here we will take log K, and this is your y axis, this is your x axis, and if you plot the graph, the nature of the graph is straight line and slope is negative, so it is like this. Slope is negative, so it is like this. So if you plot or if you calculate a slope, so slope is equal to minus EA by 2.303 R. EA by 2.303. And if you want to calculate the activation energy, so we'll rearrange it. EA is equal to minus slope into 2.303 R. So by using this equation, you can find out the energy of activation. So this is the first method. This is the first method by a graphical method. This is first method, that is called as a graphical method. So graphical method means we have to plot a graph, and from that graph you can find out the slope. By using that slope you can find out the value of energy of activation. So this is a graphical method, and there is intercept on log K. Intercept on log K, which is equals to log A. So this is our intercept. So this is our first method, that is called as a graphical method. By plotting the graph of log K versus 1 by 2, you can find out the slope, and by using the slope you can find out the energy of activation. This is our first method. This is our first method. So to find out energy of activation by graphical method, then we will see the second method, analytical method. Second method is analytical method. Okay. Now we have equation. We have equation 3, that is log K equals to log A minus EA by 2.303 R 1 by T. So we have derived in first step, in first method, graphical method, this equation we have derived. Now we will assume let K1 and K2 be the rate constant at two temperatures T1 and T2 respectively. Then above equation becomes. Now for example, there are two temperatures, temperature T1 and temperature T2. Now here I have written T in capital letters. Here I have written T in capital letters in both temperature. That means this T, this temperature is in Kelvin. This temperature is in Kelvin. Please remember this. The temperature is in Kelvin. If small t is there, then the temperature is in degrees Celsius. Now here in this equation, capital T is there. That's why you have to take the temperature in Kelvin and not in degrees Celsius. Okay. Now we will assume there are two temperatures, T1 and T2, and for these two temperatures there are two rate constant, that is K1 and K2. K1 is for temperature T1 and K2 is for temperature T2 respectively. Then the above equation becomes. So first we will write the equation temperature 2. That we will write the equation temperature T2. This is your equation for temperature T2. ये आप लोगों का कौन सी इसके लिए temperature T2 के लिए. So what we'll put the value of K. So instead of K we'll give the K2 because it is a rate constant of temperature T2. Then log A minus EA by 2.303 R into 1 by T2. Why? Because temperature कौन सा यहाँ पे T2 है. So this is your first equation. Then we will write the equation for temperature T1. We will write the temperature for T1. Now please remember that this T1 is less than T2. T2 is always higher than T1. Please remember this. Please remember this. T2 क्या होगा आपका higher temperature होगा. Now we will put the we'll write this equation in case of temperature T2. So log K, so we'll put K1 here because this is temperature T1. Then log A minus EA by 2.303 R 1 by T1, because here temperature T1 is used. So these two equations are there for two different temperatures. Now what we will do, we will subtract equation 5 from 4, because we will subtract the equation 5 from 4. Okay, so here we will subtract, here we will subtract this equation, equation 5 from equation 4, and after subtracting we will get this equation log K2 minus K1. We will get this log K2 minus K1 equals to EA by 2.303 R T2 minus T1 divided by T2 into T1. This is your equation. This is your equation. Okay. So this is the graphical mass. This is the analytical method. So by using this equation, you can find out the energy of activation. We will rearrange it and we will find out the energy of activation. Okay. If you have understood these two methods, we will go to the problems. We will go to the problem section. So that is numericals based on energy of activation. So please tell me, have you understood these two methods? अगर नहीं भी समझ में आए ना, तो while solving problems these two methods will get understand. आप लोगों को ये दोनों methods problem solving में अच्छी तरह से समझ में आएंगे. ठीक है? So shall I start the numericals based on energy of activation? Yes or no? Shall I start it? So two problem we will discuss here. Two problem we will discuss. इसके ऊपर हमेशा क्वेश्चन रहता है. Rutik Pawar is saying yes sir. What about others? Only Rutik is, Vaibhav is also saying, Pramodin is also saying. ठीक है. So take a pen and notebook and write down this problem. Take a pen and notebook and write down this problem. Problem number 1. क्या है problem number 1? I will read. I will dictate you. You will write. You can write down. Huh? So problem number 1. The temperature coefficient of K35 by K25 for a saponification of ethyl acetate by NaOH. So here reaction is saponification reactions of ethyl acetate and in presence of base, that is NaOH. This reaction is there, and temperature coefficient you have given K35 by K25, which is 1.82, which is 1.82. Calculate the energy of activation in calories. So you have asked to calculate the energy of activation in calories, and what you have given? You have given R, that is gas constant, 2 calorie per mole per degree. So write down this problem and tell me the given. आप लोगों को given क्या है? That you have to write first. So this is your problem number 1. The temperature coefficient of K35, K25 for the saponification of ethyl acetate by NaOH is 1.82. Calculate the energy of activation. Now here K35 and K25 is given. That means it is a rate constant for two different temperatures. It is a rate constant for two different temperatures. K35 is temperature T2. K35 is a temperature T2 and K25 it is a rate constant for temperature T1. Write down the given equation. What you have given? Tell me. What you have given? You have given temperature coefficient. That is K35 by K25 you have given. That is 1.82. Correct? Yes or no? Then आप लोगों को क्या दिया है? R is equal to दिया है 2 calorie per mole per degree. ठीक है? Then tell me the value of temperature. What will be the value for temperature T1? T1 के लिए क्या वैल्यू आ जाएगी? What is the value for temperature T1? So I will write here temperature T1 is 25. Correct? Temperature T1, that is small t1, is 25. Rutik. Now tell me in Kelvin. Temperature T1 in Kelvin. So I will here write solution. And in solution I will write first given. So what we have given? Correct, Rupesh Kumar. T1, capital T1 is 298 Kelvin. Very good. So आप लोगों को क्या गिवन है? आप लोगों को गिवन है K35 by K25, which is the temperature coefficient, and it is 1.82. This we have given. Then T1, that is temperature in Kelvin, is given 298. Correct. And temperature T2. Temperature T2 is Sneha. T must be capital. Temperature T2 is 308. This you have given. And you know the equation now. This is our equation. आप लोगों को इक्वेशन पता है? क्या है इक्वेशन? इक्वेशन इज नथिंग बट log K2 by K1 equals to EA divided by 2.303 R T2 minus T1 divided by T2 into T1. This is our equation. ठीक है? This is our equation. Now we will just put the values in this equation. What we will do? We will put the values. क्या है? So I will write here log K2 by K1 is given. So here K2 by K1 is equals to this. K2 by K1 is equal to this. K2 by K1 is nothing but the K35 divided K35 by K25, which is equal to 1.82. So 1.82 log of 1.82, which is equal to EA. EA we have to find out. So here 2.3 2.303 into R. R is what? R is 2. R is given. It is 2. ठीक है? 2.303 R T2. Then what is T2? What is T2? T2 is 308 minus 298 divided by 308 into 298. And if you solve this, if you take a log of this, log of 1.82, it will come 0.2601. Then EA, that is energy of activation, and if you multiply this, you will get 4.606 into 308 minus 298. It is 10. So 10 divided by, and if you multiply it by 308 into 298 is 91784. And if you solve this equation in terms of energy of activation, you will get 10966 calorie per mole. You will get this equation, 10966 calorie per mole. And if you want to write this kilocalorie per mole, so it will become 10.966 kilocalorie per mole. So in this way you have to find out you have to calculate the energy of activation. Understood how to calculate the energy of activation? Yes or no? Have you understood the energy of activation? How to calculate the energy of activation? So what you have to do? You have to first write down the given. So here K2 by K1 is given, which is nothing. K2 is nothing but the K35. K1 is nothing but the K25, which is equal to 1.82. So this coefficient, temperature coefficient is given. Then value of temperature in Kelvin is given. T1, which is 298. T2 is 308. Then you have this equation, that is we have derived in second method, that is in analytical method. Log K2 by K1 is equal to EA by 2.303 R T2 minus T1 divided by T2 into T1. So just you have to put the values of this ratio K2 by K1, then put the value of R, which is given 2 calorie per mole per degree, then put the value of T2 minus T1, divide by it T2 into T1, and after solving you will get the energy of activation. You will get the energy of activation. So you have to rearrange this equation. You have to rearrange this equation in terms of energy of equation, and you have to just do the multiplication and division. You will get the value. Now the problem number 2. So प्रॉब्लम नंबर 2 आपके स्क्रीन पे है. राइट डाउन दिस प्रॉब्लम नंबर 2 for a given reaction. Now here reaction is unknown. Here reaction is unknown. They have just given a reaction. For a given reaction at 25 degree. So temperature is given to you at 25 degree. Rate constant doubles. Rate constant, what happens to the rate constant? It gets doubles. When temperature is increased by 10 degree, what is the energy of activation for the reaction? What is the energy of activation for the reaction? So you have to calculate. Again here you have to calculate the energy of activation. And what you have given? A reaction is given. That reaction is unknown. And the temperature of that reaction is 25 degrees Celsius. And what happens to the rate constant? If you increase the temperature by 10 degree, that means this is your reaction temperature 10 degrees Celsius, and if you increase these reactions by 10 degree, that means if you add or increase this reaction, that means if you perform this reaction at 35 degree, then what happens to the rate constant? Rate constant decreases. Rate constant, very good Rupesh Kumar. Rate constant increases, or rate constant gets double. Rate constant gets double. So here uh, T1 is 25 degrees Celsius. T1 is 25 degrees Celsius and T2 is 35 degrees Celsius. And here if you write in terms of Kelvin, so here T1 is 298 degrees Celsius and T2 is 308 degrees Celsius. Okay. Now what they have given? So here I will write the solution. Here I will write the solution. They have given R is also 2 calorie per mole per degree. They have given temperature T1 and T2. And this ratio, that means what happens to the rate constant? What happens to the rate constant? Rate constant get doubles. Rate constant get doubles. So this rate constant K2 becomes double of K1. So this is the equation. K2 becomes twice of K1. K2 becomes twice of K1 at 35 degrees Celsius. At 35 degrees Celsius or at 308 Kelvin temperature. So this ratio is given. This ratio is given. So for example, if you transfer this K1 here, so it will become K2 by K1 which is equal to 2. K2 by K1 which is equal to 2. This ratio is given to you now. K2 by K1 is given to you. Now you know that equation. This is our very famous equation. Log K2 by K1 which is equal to EA by 2.303 R T2 minus T1 divided by T2 into T1. Now here this you have to just put this value. You have to just put this value. Log K2 by K1 is nothing but the log 2. So here I will write EA, that is energy of activation, that we have to find 2.303 multiplied by 2, because R is given. R is nothing but the 2, and here if you put this value T2 308 minus 298 divided by 308 multiplied by 298. So this term is similar. This term is similar to the our problem number 1. So what we will do, if you take log 2, if you take log 2 and if you solve this equation, for example EA 4.606 इंटू, ये हम लोगों ने लास्ट टाइम सॉल्व किया था, क्या था, इंटू 10 डिवाइडेड बाय 91784. टेल मी द वैल्यू ऑफ log 2. टेल मी द वैल्यू ऑफ log 2. log 2 की वैल्यू कितनी है? log of 2 is what? What is the value for log 2? 0.3010, correct. So 0.3010, and if you solve this equation, in terms of EA, if you solve this equation in terms of EA, you will get calorie per mole. You will get calorie per mole. And if you want to write down this equation EA in terms of kilocalorie, then 12.725 kilocalorie per mole. Kilocalorie per mole. Okay, understood how to solve this? How to calculate the energy of activation? How to calculate energy of activation? Two different problems we have discussed, and this equation, which is very important, this equation you have to remember. This equation is you have to remember, that is log K2 by K1 equals to EA divided by 2.303 R into T2 minus T1 divided by T2 into T1, and just you have to solve the equation in terms of EA. So put the values, correct values, solve it and rearrange in terms of EA. You will get the value in calorie per mole, and you can write down it in kilocalorie per mole. Okay, have you understood these two problems? In the next lecture, what we will do? In the next lecture, we will solve the problems based on uh, order of reaction. We will solve based on the first order reaction, second order reactions. तो हम लोग नेक्स्ट लेक्चर में ना फर्स्ट ऑर्डर के प्रॉब्लम सॉल्व करेंगे. ठीक है. In the next lecture we will solve some problem based on the first order reactions and second order reaction. Okay, so today I think we will stop here. We will stop here. If you have any problem, based on today's lecture, you can ask me. I will give 5 minutes for that. If you have any doubt, problem, then you can ask me. After 5 minutes, we will stop here. Any problem? No problem. No problem. Sneha is saying no problem. Okay. अगर प्रॉब्लम नहीं है तो आप लोग अटेंडेंस दे सकते हो. I have activated the link for attendance. You have to write present if you have attended today's online session. This attendance link will be active only for 5 minutes. ठीक है. So give your attendance. If you have no problem, so we will stop here. In the next lecture, we will stop. Next lecture is also based on numericals. Next lecture में भी हम लोग क्या करेंगे? Numericals solve करेंगे. ठीक है? So I think today I will stop here. Take care. Bye bye. Have a good day.